Off by one errors, the Fencepost problem explained. Imagine you're building a fence around your garden. You know the length of the fence and how far apart to place each post. But when you count the posts, something feels off. That's because of a common mistake called the Fencepost problem. It's a specific kind of off by one error that trips up many programmers. In programming, off by one errors happen when you get the number of items or steps wrong by just one. For example, if you are counting elements in a list or looping through a range, it's easy to accidentally skip the first or last item. The Fencepost problem is a perfect example of this confusion. It comes up when you try to count the number of fence sections versus the number of fence posts. Let's say you build a fence that is 30 feet long, and you want posts every 3 feet. If you just divide 30 by 3, you get 10. But that's not the full story. You actually need 11 posts because there's a post at the start and one at the end. The 10 sections between the posts are what you get when you divide 30 by 3, but the total number of posts is always one more than the number of sections. This mistake often appears in code when you write loops. For example, if you want to process a list of items, you might write a loop that runs from 0 to the length of the list minus 1. But if you accidentally include the length itself, your loop might run one time too many or too few. That's why understanding whether your loop should include or exclude the boundary is so important. A common scenario is when you're moving through a line of objects, like tennis balls. If your loop checks if the front is clear and then picks up a ball and moves forward, it might miss the last ball because the loop ends before reaching it. To fix this, you can either handle the last item outside the loop or adjust your loop conditions so it stops at the right point. To avoid these mistakes, always think about whether you are counting items or measuring spans. Are you including the start and end points? Are you counting the number of intervals or the number of points? When writing loops, make sure your conditions match what you want to do. For example, use less than instead of less than or equal to if you want to stop before a certain point. Remember, the Fencepost problem is about understanding the difference between counting endpoints and counting segments. Clarifying this helps you write better code and catch off by one errors early. When you get used to thinking about whether your loops include or exclude boundary points, fixing bugs becomes much easier. It's all about paying attention to the details of your counting and making sure your code matches your intentions.